grab a few highlighters. The key word here, the key word is whatever's preceding normal distribution, which is standard. Okay? There's something called a standard normal distribution. What is that? That's where the z-scores come in. So whenever you're comparing data from different sets, you want to go and deal with a standard normal distribution. You want to standardize it. Okay? What are we talking about? So let's try this. Jay's final score in his class was 70%, with a class average of 75, a standard deviation of 5. Okay? Jasmine's final score in her class, so they're in different classes, was 60%, where the class average was 65%, and there's a standard deviation of 7. So you're getting a lot of information here. Let's just focus on both of their classes separately. Okay? So we're going to go Jay's class and Jasmine. So we're going to try to find the middle. I tried my best to, the middle is right there. So for Jay, the average was 75%. And what's the standard deviation? It's 5, right? So 1, 2, 3, 4, 5. So that'd be 80. And then count another 5. That's 85. Count another 5. That's 90. Okay. So we're going up by 5. We're going to do the same thing going down. 65 and 60. And let's do the same thing for Jasmine. What's the average for her class? 65, right? So we'll try to find the middle here. It's right about there. So that'll be 65, and then we're going up by 7. Actually count 7. That's why I did it. I wanted you to see the scale. So 3, 4, 5, 6, 7. That gets you to 72%. Add another 7. 1, 2, 3, 4, 5, 6, 7. That gets you to 79. And add another 7. 1, 2, 3, 4, 5. You might have to add 2 marks to get you to the end here, and that's 86%. Sorry, you can't see that. So we're going up by 7%. Jasmine's class, right? The standard deviation is 7. So we're also going to count 7 downwards. 1, 2, 3, 4, 5, 6, 7. It gets you to 58. 1, 2, 3, 4, 5, 6, 7. That gets you to 51. And one more. 1, 2, 3, 4, 5, 6. You might have to add a line, a mark here. That gets you to 44. So we've got Jasmine and Jay's normal curves side by side. We could have them on the same graph, but I want to have them separated. So this is a normal distribution. So you go to J, 75 was the average. Go to the highest. Which one is going to be slightly steeper out of the two curves? Looking at the normal distributions. Right? J's is going to be slightly steeper. So let's actually make that a little steeper. So we go to the middle, put a dot there. Let's go to Jasmine, 65. And so just have it a little lower than J so that we're doing justice. Okay? By it. There you go. And then you just taper it down. Oops. So we've got both of their curves. Jasmine, the same thing. Just make sure it never touches. All right, so now that we have the normal distributions, let's put a mark where J is. So J's final score was 70. So 70 is right here. That is Jay's score, right? Right there. He's at 70 mark. And Jasmine's score was 60. 60 is right about, if you count that's 58, 59, 60 is right about there. Okay. It is hard to tell right now. It is hard to tell who did better overall. It's very hard to tell. They're both below average, right? They're both further away from the mean to the left, of course. So this is where the z-scores come in. We're going to make a standard normal distribution curve. We're going to put them both on the same grid and see for sure who did better. So let's figure out the z-scores for both students. Right? Let's do that. Reminder, the z-score is what? X minus X bar over standard deviation. That's how you do it by hand. So J, let's figure out J's z-score. JZ score. I don't know, is that too early? Score is 70 minus 75, okay, divided by 5. So that would be negative 5 over 5, which is just a negative 1. It's a full standard deviation to the left, correct? Jasmine, z-score is going to be 60 minus 65 divided by 7. That ends up being negative 5 over 7. That ends up being negative 0.71. So what happened here? Can we now tell which student did better overall? Which one do you think did better? Which student did better if you look at the z-score? Would you say Jay or Jasmine? J is one full standard deviation below the mean. So further away from the mean, right? Jasmine is a little closer to the mean. So Jasmine can say, I did better than you overall. Right? Jasmine can truly say, doesn't matter what our averages were, you might have had a hard teacher marking really hard overall, the other one was a little easier on marking, so that's why your average might be higher, but we need to consider the standard deviation of the class and the mean of the class, and then we can definitely say who did better. So Jasmine did better. Okay. Just say Jasmine is closer to the mean, comma, therefore she did better overall. So you have to know what the z-scores are telling you, okay? Okay, let's put them both on the same grid here. This is a standard normal distribution. Circle the standard again. Highlight the whole thing though. What is similar to normal distribution, but what? It only has the z-scores along the x-axis. And what's my mean when I'm talking z-scores? 0, right? And my standard deviation is 1. So find the center. It's a little there are marks that are a little darker than the other ones. Those are the ones I want you to go off of. So let's go to the center and put a 0 there. And then I'm using, if you can't see that they're darker, just count 5 to the left, put a 1 there, another 5, that's a 2, another 5, that's a 3, and then we're going to do the same thing going to the left. So I'm just doing this to scale, right? So you've got 3 standard deviations to the left, 3 to the right. Go to the top, make your little mark there, taper off. Same thing here, taper off. We are not putting the percentages in, but now we can say that J is right there. And Jasmine, this would be 0.8 would be right there, 0.71 is right about there. Okay. If you were keeping track of screen time, would you want a high z-score or a low z-score? You would want a low z-score, right? You would, in that case, like if this is screen time that we're comparing, right? If we had compared their screen time, right? You would want to be, like in that case, lower z-score. Like the further away from the average you are, the better it would be, right? On the low end, actually, if your z-score is positive, then you're spending more screen time hours than the average, right? So let the z-score, you just have to understand it. Let it use it within the context to see definitely. But when it comes to scoring, like on a overall, who did better in a class, the higher z-score is always the better choice. Okay, so here we go. Note, when talking final scores, I'm going to summarize it. I'm not going to give you the whole thing that I have here. When talking final scores, a higher z-score is better. Okay. Use context and knowledge of z-scores to answer question. Okay, that is a big one there, right? I want you to use the problem, like what is the question talking about, and what you know about z-scores to inform your final decision. We're all pretty good at calculating things, but when it's explaining time, that's where it takes it up another level, right? What are z-scores? Z-score tell us 2 things, right? How many standard deviations away you are from the mean, and also whether you are below it or above it. Okay, that's what it's telling you. So the sign tells you something, and the number itself tells you something else. Right? So keep that in mind. All right, so now you try it on the AC. Okay, give it a try.